Welcome back. We are going to continue working on our geometry review for the ACT and MCA tests. We're starting with question 11 here. It says find all of the angles in an isosceles triangle if each base angle is 4 times the size of the apex angle. So picture an isosceles triangle, and we know that two sides have to be the same, which means the base angles have to be the same. And it says the base angle is 4 times the size of the apex angle. So if we call our apex angle x, that means each base angle is 4 times that, so 4x degrees. And all of the angles in a triangle have to add up to 180, so if we take 4x plus x, we should get 180 degrees. So 9x equals 180, x would have to be 20. So the apex angle is 20 degrees, and the two base angles would each be 80 degrees. All right, question 12, it says right triangle ABC has angle bisector BD. So if BD is an angle bisector, we know that these two angles have to be the same size. And we also are told that angle BDC is 120 degrees and side AB is 10. It says to find all missing angles and sides. So if we look at this 120 degree angle, we know that since we have a straight line here, this angle has to be 60 degrees since they have to add up to 180. And that makes this upper angle here 30 degrees to make that triangle add up to 180. So we're dealing with a 30, 60, 90 triangle. So when we have a 30 degree angle, the side opposite we call x. The other leg we call x root 3. And the hypotenuse is twice the length of the short leg. So 2x. So that's typical, that's standard for a 30, 60, 90 triangle. So what we know is that this side is 10, which would be this side. So that means that this x root 3 must equal 10. If we divide out the root 3, we have x being 10 divided by root 3, rationalized, which we typically do. We would times both by a root 3. And we'd have 10 root 3 divided by 3. All right, so our short leg is 10 root 3 divided by 3, and that would be side AD. All right. Then our hypotenuse would be this side, and that is this one, so that's our 2x. And if x is 10 root 3 divided by 3, we have to double that. So side BD has to be twice our 10 root 3 divided by 3. So that would be 20 root 3 divided by 3. All right, so we have everything in that left little triangle, angles and side measurements all figured out. Looking at the whole triangle together, if this upper angle is 30, this also had to be 30 since the red line there is an angle bisector. So again, we have a 30, 60, 90 triangle. Make that a little more accurate. So this is 60 degrees up here, 30 degrees here. And again, looking at our sides, the short side would be x, the long side would be x root 3, and the hypotenuse would be 2x. So this x, all right, so if side AB is 10, which is what we were given, then we know side BC, the hypotenuse has to be twice that. So that would have to be 20. We can figure out our base AC here is x times root 3, and we know x is 10, so it would also be 10 root 3. All right, so we have all of our sides and all of our, I take that back, we still need to figure out side DC right there. So we know that AC is 10 root 3, and AD is, where did we have that? AD was 10 root 3 here. All right. 10 root 3 divided by 3. And side DC here is just the difference between those two lengths. So we're going to have to subtract. So side DC is going to be AC minus AD. 10 root 3 minus 10 root 3 divided by 3. Getting a common denominator, we'd have to think of this as 30/3 instead of a 10. And so 30 minus 10, we'd have 20 root 3 divided by 3 for side DC. All right, question 13. It says find the length of the minor arc AB if we know that angle AOB is 40 degrees and the radius of the circle is 5 and it has center O. All right, so they didn't give us a picture. Let's figure out what that would look like. All right, we have a center O. We are told that we have this arc AB and we are told that angle AOB is 40 degrees. All right, it says the radius is 5, so we've got our picture labeled. And this arc AB is a piece of the whole circumference, all right? It's just a portion of it. So if we think about going all the way around our circle, right, that's 360 degrees. We're just looking at a 40-degree chunk of it. So arc AB is 40 out of 360 degrees. That's the portion of the circle used by this angle. And so that is the portion that this is compared to the whole circumference. All right, so we need this fraction, 40 out of 360, of the whole circumference. And our circumference is 2 pi r. So we have 40 divided by 360 times 2 pi, and our radius was 5. All right, so multiplying that, 2 times 5 would be 10, times 40 would be 400. So we have 400 divided by 360 times pi. All right, we could reduce that. We can divide out a 40 from each one. So we'd have 10 pi divided by 9 for a reduced arc measurement. All right, question 14 says find the circumference of the circle given that BC is 12 feet. All right, so notice that the angle they're giving us here is not a central angle. Its vertex is on the circle itself. If we make an angle from the center, all right, that angle measurement is twice as big as this little angle A of 45 degrees, which makes this a right angle, 90 degrees. We also know that we have an isosceles triangle, and each of these sides would be the radius of that circle. So we really have a triangle that has a 90-degree angle. We have two sides that are the same. And they're asking us to find, they're telling us that this measurement is 12. So to find the radius of the circle, which we would need in order to find the circumference, we can use the fact that we have a 45, 45, 90 triangle here. Since it's isosceles, our base angles have to be equal. And in a 45, 45, 90 triangle, if one side is x, the other is x, and the hypotenuse is x root 2. So in our case, the two missing sides are called the radii of that circle. We know that x root 2 has to be a 12. So x, which is our radius, will be 12 divided by root 2. Again, if we rationalize that, we have 12 root 2 divided by 2, which reduces to 6 root 2. All right, that is the radius of our circle. Now, circumference is 2 pi r. So 2 pi times 6 root 2. So we end up with 12 pi root 2 for the circumference. Question 15 says find the surface area of a sphere whose volume is 121.5 pi. They also give you the formula volume equals 4/3 pi r cubed and surface area is 4 pi r squared. So they're looking for the surface area. We know the volume. So this 4/3 pi r cubed is 121.5 pi. Since both sides have a pi on it, we can reduce that out, divide it out. So now we have 4/3 r cubed is 121.5. To solve for the radius, we would have to multiply both sides by 3/4. So now we have r cubed equaling 121.5 times 3/4 is 91.125. To find r, we have to cube root that. So our radius ends up being 4.5. Now to find surface area, we need 4 pi r squared. So surface area is going to be 4 times pi times 4.5 squared, which ends up as 81 pi. All right, question 16. Find the probability that a point within the region y is less than negative absolute value x plus 4 plus 1 and y is greater than or equal to negative 3. Find the probability that a point in that space is also in the region where x is greater than negative 2. All right, so let's go to a new page here and get a grid. All right, so we know that we have this equation. Y is less than negative absolute value x plus 4 plus 1. We also know that y has to be greater than or equal to negative 3. We want to create that region. So thinking about our transformations, absolute value graphs are that V shape. This one has been shifted left 4 and up 1. And it's also been reflected over the x-axis. So if we take our vertex, we shift it left 4 and up 1, we land there, and we have flipped this upside down. So we have a negative 1 slope. All right, so we have this region for the absolute value part, and it says y has to be less than that, so we need to be underneath that V shape. We also have to be greater than or equal to negative 3. So we have to be above this line. So we're really looking at the space inside this triangle. All right, we need to find the area of that space. So the area of our red triangle is 1/2 base times height. Our base, if we count squares from here to here, our base is 1, 2, 3, 4, 5, 6, 7, 8. Our height is from here down, which would be 4. So 1/2 times 8 is 4. 4 times 4 is 16. The space inside that red triangle is 16 square units. Now it says find the probability that a point in that 16 square units is also in the region where x is greater than negative 2. So we want to have x greater than negative 2 would be here. So we're looking for what is the area of this little triangle. All right. So the area of our purple triangle, again, is 1/2 our base times our height. In this case, our base is 2, and our height is also 2. So 1/2 times 2 is 1, times 2 is 2. So the probability that a point in the red triangle is also in the purple triangle would be the area of the small one compared to the area of the big. So our probability would be 1/8. right. Question 17, it says the points 4n and 8m are on a line that is perpendicular to 4x minus 5y equals 20. Find the positive difference between m and n. All right, so if it is perpendicular to this line, let's figure out the slope of that line, and then we can find the slope of our perpendicular line. So we've got 4x minus 5y equals 20. Solving for y, we've got negative 5y equals negative 4x plus 20. Dividing by negative 5, we've got 4/5 x minus 4. So our original line is 4/5, which means our perpendicular slope is the opposite reciprocal. It needs to be negative 5/4. Now we know slope is y2 minus y1 over x2 minus x1, and we want our slope to be negative 5/4. So if we plug in our y coordinates, which are the m and the n, so m minus n, compared to our x coordinates, 8 minus 4, we are supposed to get negative 5/4. Well, if you look at the denominator, 8 minus 4 is 4, so 4 does equal 4, which means that m minus n has to be negative 5. Now they asked for the positive difference. So we chose to do m minus n. We could have also chosen to do n minus m. It just depends on which point you start with. So our positive difference would have to be n minus m to get a positive 5. All right, our last question. It says an octagon has 2 right angles and 6 other congruent angles. What is the measure of each of the larger angles? The sum of the angles in an octagon, or in any polygon, is n minus 2 times 180. So if you take any kind of polygon, say, we'll just start with an easy one, 4 squares, or 4 sides, we can make 2 triangles out of it. All right, so there were 4 sides, but we can only make 2 triangles, so 4 minus 2, 2 triangles, each is 180. If we had a pentagon, we can make 3 triangles. Okay, again, it's n minus 2, so 3 triangles times 180 to get the total number, the total measurement of your angles. So if we have an octagon, that means n is 8. So the sum of all of the angles would be 8 minus 2, or 6, times 180. 6 times 180 is 1080, but that's the whole octagon. Now it says it has 2 right angles, which are each 90 degrees, so that uses up 180 of this. So if we take away 180 degrees, we are left with 900 degrees. And it says, what is the measure of the larger angles? There's 6 other congruent ones. So we have to take this 900 degrees that we have left and divide it into 6 equal parts. And so each of those other angles would be 150. So in this octagon, we have 2 right angles, and the other 6 are 150 degrees.